Hello, everybody. This is Jimo. Today I will still be treating calculus, and particularly I will be explaining integration. Excuse me. So in my previous video, I explained that integration is divided into two. We can have definite integral, and we can also have indefinite integral. So in my last video, I explained what I mean by indefinite integral. So today I will be working on definite integral. So today it will be definite integral. So given that we have a continuous function, given that or given, let me say, given a continuous function f of x, the symbol to represent the definite integral is given as integral of a to b f of x dx. We can say this is equation 1, where a is the lower limit and b is the upper limit. So the solution, you can write therefore the solution to equation 1 is as follows. You have a, b, f of x dx will be written as x n plus 1 over n plus 1. Then you have the limits, or sometimes it can be written as this. You have a and you have b. So we can see that what we have here that is different from what I have in previous video is just the two limits. So as I explained before, you are gonna add 1 to the power of x, and you are going to divide that power. You are going to divide x by the power. So most often time, whatever you have here is the same as what is gonna be here. Let's take some examples. Example 1. This is just a very simple one. Evaluate 3x squared dx. Our score booster solution is y is equals to we are just going to rewrite the question in this form. Yes, good. So remember what I have said. This is the power of x. So if you compare this with this, okay, so we're gonna have it that our y is gonna be 3x 2 plus 1 over 2 plus 1. Okay, for simplicity, a b. Sorry, now I've been given the a and the b, so it's going to be what is my a? 0, and what is my b? 1. Okay, so I'm gonna have 3x raised to power 3, that's 2 plus 1 over 3, right? And I'm gonna have my limits. So 3 cancels 3 here. So I'm gonna have x raised to power 3 is 0 and 1. Now I'm gonna use the limits. So the first limit is 1, so it's going to be when x is equals to 1, it means I'm going to have 1 raised to power 3 minus when x is equals to 0, I'm gonna have x raised to power 0. 1 raised to power 3 is 1, 0 raised to power 3 is 0, and my final answer is 1. As simple as that. So let's look at another example. Example 2. So example 2 says evaluate integral of 1 4 into x raised to power 2 plus 2x minus 5 dx. So let me just try to minimize space here. So score booster solution goes thus. So we're gonna just write it in this form: y is equals to integral of 1 to 4 of s squared plus 2x minus 5 dx. And what we are going to do here is to use the sum rule that says if you have summation of functions like this, you can integrate each of the terms one after the other, and you then add everything. So I'm going to use, let's say y is equals to I mean the first one is y1, so we're going to have y1 is equals to s s squared, right? Okay, so let me write it fully. We're going to write y1 is equals to integral of 1 to 4 of s squared. That's this first one, and I'm going to have it as s cubed over 3, 1 and 4. And if I substitute this one, okay, it's gonna be I'm going to substitute for the 4. It's going to be 1 over 3 into 4 raised to power 3 minus 1 over 3 into 1 raised to power 3. And that will be 1 over 3, 3 raised to power, 4 raised to power 3 is 64. That's times 64 minus 1 over 3. 1 raised to power 3 is still 3. Sorry, this is 3. So what I'm going to do here, what I have here is now says 4 over 3 minus 1 over 3. So when you have things like this, since both the denominator are the same, so you just subtract this one. So it's going to be 64 minus 1. That is 63 and over 3. And this at the end, 3 here, 1, 3 here, 2, 1. This gives us 21. And that is y1. Again, I'm going to call this one y2. It means y2 is equals to integral 1 to 4 of 2x raised to power 1. Let me just put the 1 for explanation's sake, and this will be 2s squared over 2 1 4. Okay, 2 cancels 2 here. So I'm going to have s squared 1 to 4, right? So what will happen is that I'm going to have 4 squared minus 1 squared. 4 squared is 16 minus 1 squared, and this will be 15. Now I've done this, so I'm left with this now. So y is equals to, I'm going to say y3 is equals to 5 or minus 5 if I like. So now I will say y3 is equals to integral of 1 to 4 minus 5 dx, right? So again, I'm going to integrate this one. If I integrate this, it's going to be 5x. I believe you understand this. I explained it before, 1 and 4. Okay, so what we're gonna do here is minus 5, okay, into 4, then minus 5 into 1. So this will be 5 times 4 minus 20. Then sorry, this will be minus because the function itself is minus, so it's going to be plus 5. So our answer at the end is going to be minus 15. Another way you can look at it is that you can write y is equals to 3, 1 and 4 minus 5 dx. Then I said you can rewrite this one as this, okay, and that will be minus 15. Now remember, our y, we are looking for y will be y1 plus y2 plus y3. Okay, so now our final answer is going to be y is equals to 21, which is y1 plus 15 which is y2 minus 15, which is y3, and that will be 21. So this is the final answer to the example 2. Now let's take one more or one or two more example. Excuse me. So example 4. Example 4. Okay, it's fucking fine. So this time, example 4, I'm gonna take it from a jump question. So it is UTME or jump now 2012. So the question is evaluate integral of 1 to s squared minus 4x dx. So our ScoreBooster solution is like this. So we just put it in this form: y is equals to integral from 1 to 2 of s squared minus 4x dx, right? So instead of writing y1, y2, y3, I will assume that now you can handle integration of polynomial. So I will just integrate each of the terms one after the other. So this means I'm going to have x raised to power 3 over 3 minus 4 s squared over 2, 1 to 2, right? So now for the upper limit is going to be 2 raised to power 3 over 3 minus 4 into 2 raised to power 2 over 2 minus the lower limit now is going to be 1 raised to power 3 over 3 minus 4 into 1 raised to power 2 over 2. I hope we can see that. So you can begin simplification here. This is just what you can easily do as a JAM student. So 2 cancels 2 here. So let's factorize this. Let's simplify this. This is 2 raised to power 3 is 2 times 2 times 2, which is 8. And 2 raised to power 2 here is 4, okay, times 2, which is 8. And this is minus 1 over 3. And this is plus 1 raised to power 2 is 1. So this 2 also cancels this 2 here. If I like, I could have cancelled the 2 from here, but unfortunately this 4 and 2 escape and come to the next step. So I can cancel still when I get to the next step, but this could have been easier for me. So this is 1 raised to power 2, which is 1 times 2, and this is 2. Now what I will advise here is it will be easier for you to handle this equation, this part, by considering the fraction and the other number, whole number separately. So what we're going to do here is I'm going to bring the fractions together. I'm going to have 8 over 3 minus 1 over 3 minus 8 then plus 2. I hope this is clear, right? This is minus 8, this is plus 2. Brought them together, 8 over 3 and minus 1 over 3 brought them together. Since these two are having the same uh, denominator, so it's very easy. So don't forget to put is equals to, especially so 3 3, you're just gonna have 8 minus 1, which is 7, then minus 8 plus minus 8 plus 2, that's minus 6. Now another thing is, instead of finding LCM blah blah blah, I think it's easy to just write this form: minus 18 over 3. 18 over 3 is the same thing as 6, so we just have 7 minus 18 is 11 over 3. 7 minus 18 is minus 11, and 3 here, just write the 3. I am trying to jump a lot of steps here because you will be writing jump, and in jump, believe me, you don't have time. You just get to be fast. Jump is testing your speed and your accuracy. These two things are very, very important in jump. So this is example 3. Now let's look at the last example, example 4. I want to start from a new page. Example 4. So example 4 goes thus. So it's a jam question, I think. It's a jam question, and it was taken from, okay, I'm gonna make sure I put a function passes through the origin, and its first derivative is 3x plus 2. What is f of x? That's a question. So I want to check where did I get this question. I want to check to make reference. This is very important, so please give me some time. I think it should be 1990 something. Seems people of previous generation, they have their question a bit more difficult, maybe. I may be wrong, so I may be wrong. So this is I found where I got it. This is which year? Come on, excuse me. Okay, 2000. This is 2000. Year 2000. Is it 2000 or 2001? Sorry, just want to make sure I give you the right thing. This is 2001. No, it's 2000. UTME 2000. So the score booster solution is we look at this as just integration. A function passes through the origin and its first derivative is this. So say let's the first derivative be dy dx is equals to f of x prime. Therefore, f of x prime is equals to what? 3x plus 2. So f of x is just an integration. 3x squared over 2 plus 2x over 1. Just kidding. Oh, because 1 is nothing. Okay? And plus c. Don't forget. This is close to definite or indefinite integral. But in this case, we are because we are not given the boundary. Okay? Because I just brought it here because I didn't solve a question like that while I was treating indefinite integral. So just take it like that. So at the origin, we are told that f is equals to 0, f of x is equals to 0, and sorry, it's right, but I just want to make things to be in order. Say x is equals to 0 and f of x is also equals to 0. Therefore, substitute for f of x, 0 is equals to, substitute for 0, 0 squared over 2 plus 2 times 0 plus c. So the whole of this is 0, 0, and c. Therefore, c is equals to 0. If c is equals to 0, it means here this c is nothing. So your f of x is equals to what? 3 over 2 x squared plus 2x. This will be your final answer, right? So with this I conclude the topic definite integral under integration. Before I go, as I normally do, I will give you some exercises. 1. Evaluate integral of 0 to 1 of 3 minus 2x dx. This is UTME 2011, and your answer is supposed to be 2. Number 2. Evaluate integral of 0 to s cubed plus s squared dx. This is UTME 2, okay, not 2000, okay, yes, 2010. And your answer is supposed to be 6/2 over 3. Then number 3, evaluate again -1. You can see it seems the question are somehow similar, but not the same anyway. UTME 1994, and most likely your answer will be 4 whole number 2 over 3. Then number 4, if y is equals to x into s raised to power 4 plus s squared plus 1, evaluate integral of -1 y dx, and this is UTME 1997, and your answer is most likely 0. Number 5, evaluate 2 3 s squared minus 2x dx. This is UTME 2003. The answer, find it yourself. Number 6, if the y dx is equals to 2x minus 3 and y is equals to 3 when x is equals to 0, find y in terms of, so that the English people will not kill me, in terms of x. This is UTME. Which year is this? I need to check which year is this. I will find it out later. So I want to give you int here. Just integrate, then find the constants. So most likely your answer will be, is gonna be y is equals to s squared minus 3x plus 3. And number 7, which is the last one, integrate s squared minus x over x with respect to x. This is UTME 2007, and the answer is s squared over 2 minus 2x plus k. So just give me some time to find out the answers to some of these things I gave you, and also the year. This is 2003, I think. This is UTME 2003. And what about this? This number 6, I want to find the year which okay, let me give you this one. the answer is most likely gonna be 4/3, and if the y dx is equals to c, when I can find it. This one is most likely, can't remember the year, but it doesn't matter. It's a jump question, so just try your errors on it. So this the end of this topic in definite integral. In my next video, I am going to take the next topic as stipulated by jump. So it's going to be integration of trig function. So before then, please work out all this exercise, and I want to say thank you for listening. Have a nice day.